Why does shadow IT persist? Well, it usually comes down to a massive gap between the speed of business and the speed of IT processes. Say a new AI tool sits under review for months, so a manager just says, hey, put it on your expense account. Suddenly, you've got software running with absolutely no contract. Or maybe an employee decides to use Dropbox, or a supplier only wants to send files over WhatsApp. When IT simply says no without a clear explanation, employees just bypass security to get their work done. Data leaves the building, visibility totally vanishes, and major risks emerge. It's a reality every organization has to confront.
Today's agenda covers exactly why this happens. We'll be breaking down the two layers of the shadow IT problem, the organizational politics at play, a realistic three-stage management model, three specific mechanisms for handling exceptions, and the practical first steps you can take. Section 1. Causes of shadow IT. Let's look a bit closer at why this persists, despite all those strict company policies. Like we just mentioned, maybe a customer really prefers Dropbox, or a key supplier only transmits files over WhatsApp. When IT takes months to review new tools, the business doesn't just stop. Managers expense software without any formal contracts. Employees shift their work to personal laptops or start using cellular SIM connections. Basically, the immediate needs of the business completely outpace standard IT processes. And here's the real kicker. When users bypass your controls, your visibility disappears. But the liability? That absolutely stays right where it is. Regulations still mandate strict compliance. The organization carries all the risk, and heavy fines still apply if employees process regulated data on unmanaged devices. Simply blocking things just pushes the work out to the very edges of the network, to personal laptops and mobile hotspots. The company retains the liability, but loses all the insight. So you end up with this classic standoff. Employees experience frustrating delays waiting for approvals, and those delays practically invite workarounds. Meanwhile, IT experiences massive risk when devices and apps operate in the shadows for months, sometimes even years. That gap creates huge exposure. Building real security requires trust, and trust requires explanations rather than flat refusals. A flat no is essentially just an invitation to work around IT. Section 2. Layers of shadow IT. This problem actually operates across two distinct boundaries: the network layer and the application layer. You really have to look at this as a two-layer problem. At the network layer, you're dealing with unauthorized physical devices, things like rogue routers, 5G modems, personal hotspots, and unmanaged IoT devices. Network Access Control, or NAC, addresses this perimeter down at layer 2. But then you have the application layer. This is your browser-based SaaS, unapproved remote access, and unauthorized cloud storage. Because users can access these tools without installing any actual software, IT completely lacks visibility. The browser itself acts as the client, so your controls have to adapt. To handle both, Genian unites these controls through universal ZTNA, which is fundamentally NAC-driven. Here's why that matters. NAC controls the network perimeter at layer 2, using node grouping and ARP enforcement. Zero Trust Network Access, or ZTNA, secures the application layer, those SaaS sessions and distant cloud connections. But ZTNA without NAC stops at access. It can't see layer 2. And NAC without ZTNA stops at the network perimeter. Together, though, you cover both layers of shadow IT on one single platform. Moving on to Section 3, Politics within organizations. Shadow IT isn't just a tech problem. It creates serious political conflicts between departments. Think about IT versus network operations. Security obviously requires control, but operations teams desperately want to avoid network changes to prevent downtime. They naturally want to stall NAC deployments. Genian NAC resolves this conflict by operating from a standard access port. The platform uses ARP enforcement without requiring complex 802.1x switch reconfigurations, so deployment happens without disruptions. You also have the conflict between IT and the business side. Again, the debate isn't really about whether exceptions exist, but rather how you handle them without breaking operations. Section 4. Stages of management. Getting a handle on all of this follows a specific three-stage model. This model moves smoothly from visibility to classification and finally to managing exceptions. First, visibility requires sensors. Then classification requires accurate data. Finally, management requires formal records to handle those inevitable exceptions. You know, discovery absolutely has to precede policy, and understanding has to precede any kind of blocking action. In Stage 1, administrators just connect the sensors without making any changes to switch configurations. The initial inventory is usually complete in 2 to 3 days. Genian's Device Platform Intelligence, or GDPI, identifies the exact platform, its end-of-life status, and specific CVE vulnerabilities per device. Keep in mind, just because a device is unknown doesn't mean it's malicious. An unknown device sitting on a flat network indefinitely is a totally different problem than active malware. Identification is always the first step. In Stage 2, every category gets a specific node group. You've got endpoints accessing the main network, guests out on the internet, and so on. But what about unclassified shadow IT devices? They get placed into a restricted node group. They are visible, but restricted, rather than just hitting a flat block. Each group has its own node policy and enforcement method, whether that's ARP, 802.1x, SNMP, or an agent. Then in Stage 3, you simply move devices to the right group as their ownership is confirmed, reviewing it periodically. Section 5. Mechanisms for Exceptions. Chapter 5 of the Genius Admin Guide documents exactly how to handle this. There are 3 main documented mechanisms. First, condition-based dynamic node groups. Every device is classified by type, platform, or user and placed into a group with a specific node policy that matches its risk level, so it's not just a binary yes or no. Second, the Captive Web Portal, or CWP. When an unregistered device connects, the CWP presents a form. The admin approves or denies it, and the approved device moves to the appropriate group, covering IPs, users, and guests while creating a clear audit record. Third, tag-based temporary access. This grants temporary permissions or policy exemptions that expire structurally. It's not just a memo. The tag actually expires, and the node reverts to default. So rather than acting as a rigid gatekeeper, Genians operates as an exception engine. Blocked devices literally cannot get an IP address via DHCP. But when administrators do grant exceptions, the system logs every single event. Those audit logs mean exceptions become fully explainable events. It structures the reality of your network so your environment can survive those inevitable workarounds, and your security controls actually absorb the realities of daily business. Section 6. Steps for Action. Let's look at how to actually start this process based on the facts. The first steps are simple, and the software editions match the implementation stages. The Basic Edition builds your inventory. The Professional Edition segments your devices into those node groups, and the Enterprise Edition automates the workflows. You can test all of this out with a 30-day trial at genians.com. There's no mandatory sales call and no hardware replacements required to get started. You get to evaluate the facts and build real value before you ever have to upgrade. As those temporary tags expire and administrators review the exceptions, a crucial question usually emerges. Does a formalized process need to replace this workaround? Shadow IT is always going to persist in dynamic environments. True security comes from reflection and adaptation. So ask yourself, is your organization managing reality, or are you just trying to block reality?